Just one more minute when we can start. All right, so let's begin this presentation. Welcome everybody. Today I'm going to talk about the from time to binary, how exploitation of insecure random in mobile apps. So let's begin. Will be our agenda for today. We are going to talk about some vulnerable applications. Then we are going to do some reverse engineering. I'm going to explain to you about some insecure randomization. We are going to do two different types of exploits, which is a time-based and a binary search. We are going to also talk about the automation tool. And then I will show you some use cases. First of all, let's introduce myself. My name is Allan. I'm also known in the security community as Paradox. It's my nickname. I'm a senior security engineer. I'm also graduated. I have some certifications like the CPT or ACP. I have a blog post which I write in content in Portuguese because I'm a Brazilian. I'm from São Paulo. And my hobby is like hip hop in general. I just like hip hop and the listen to the music, the dancing, and that's it about me. Let's go to the introduction. I put the disclaimer right here because this presentation, I'm not going to focus on the challenge right top. I'm going to show you two different vulnerable applications, and the focus of this application is not go through the right type challenge, but show you how I created a new way to exploit it or to solve it. Okay? I'm going to also show you how to abuse the verbose data and the mobile applications to improve our exploit. In this case, I'm going to show you an insecure random as example, and after, I'm going to show you use cases for real-life applications. All right? So let's move on. I'm going to use those applications. The first one is the Guess the Number application. The second one is the Mobile Hacking Lab Guess Me Challenge. Both applications are very similar. Right here, we can see that we have to guess a number from 1 to 100. Both applications, we have 10 chances left to try. And we have some input text fields. We have the check button, the guess button, new game button. And that's it. Before we start into the reverse engineer or understand more what those applications are doing, we have to talk about ADB. I believe most of you know ADB. ADB stands for Android Debug Bridge. It's a powerful tool for Android pen testing or Android developing. And the power of ADB comes from its flexibility. So you can debug applications using ADB. You can use the Java Debug Wire protocol for debug application. You can access files and settings. You can just pull and push files from your device. You can run some commands. You can reboot the device. You can install applications. You can uninstall it, capturing screenshots, and so on. And of course, you can automate tasks since ADB is kind of simple. You can run in your terminal, then you can automate it within some script. It can be scripted, all right? So right here is the first video that I bring here just to show you how powerful ADB is. And right here in this example, I'm just going to use the ADB to start the application by calling the main activity. then I will hit the number 1337, the lead number, in the input text. Finally, right here. Just a second. I should stop it. Okay. Right here. Just explain to you every command. I just use ADB to input a text. I just use the command, the key code tab, to just jump in from the input text to the check button, and then I simulated, I enter using the key command enter button. So I could interact with this application. I use ADB to start the application, to input some texts, and navigate through the UI using just ADB. And finally, we can also close the application using the force stop. That's it. Now we know the power of ADB. We interacted a little bit with this application. We know what this application does. So we have to guess the right number. And now let's dive into the reverse engineering. First of all, the entry point for any Android application is the Android manifest file. So this manifest file will tell you a lot about the application, what the application is doing, what activities are exported, services, broadcasters, receivers, and so on. Right here in this example, I'm just showing you the guess the number main activity, which is exported equals true. That's why I could use ADB to start up the application, because if it was exported to false, it won't be possible. And also you can see intent filters with the actions and category, which is telling us that this is the main activity with the category launcher, which means that this will be the first page for this application when it starts. So let's dive into this main activity. And right here we have a lot of information, but we are going to focus only on those information that are important to us for this talk. Right here, we have the application setting a text with the chances left. So the application tells us how many chances left we have on the screen. Also, when we win, the application also tells us if with the message you won. And once you win the challenge, the guess button is set to false, enabled equals to false, because once you guess the right number, you don't need to guess it anymore. Right here, also, the application tells us to enter a higher or a lower number. It's part of the game. You have to guess if the number is higher or lower from the secret number. And finally, when we lose, the application will tell us what was the right number and set again the guess button to false. Because once you lose, you don't have to guess. You have to start a new game. Right here is the part of the main activity where when we start a new game. So again, when we start a new game, a random function is instantiated to generate a new random value for our guessing challenge. And if you pay attention, this random is not setting a seed value to use to generate a new number. When the random function doesn't set a seed value, by default, the random function will use the system time current milliseconds to generate this number. And this random function is insecure, and I'm going to talk about it in a few slides later. Right here, again, we have the chances left. The applications tell us. When we hit the starting, a new challenge, the application also tells us start guessing, another text. And also, our guessing button is set to enabled again. So you are resetting the game. You are trying to do a new game. So of course the guess button will be enabled again. Just have in mind, we have a lot of information. I'm telling you a lot of things about what application is doing, what type of text is being written in the application. So we have to take some notes. Have this in mind. We have a vulnerable application, a possible vulnerable application, and we have to guess a number from 1 to 100, all right? The application tells us if the value we inputted is above or below from the expected value. We have only 10 attempts to guess the right number or the secret number. The application uses an unsafe random function. When we guess the right number or we are run of tries, the guess button is disabled. And when we start a new game, the guess button is enabled again. Just have this information in mind because it will be valuable for us later. So let's talk about random. Why you are telling me that random is unsafe, insecure, and why should I believe it? Right here on the right side, I just bring you a picture from the J shell importing the Java util random, and I instantiated two different values, the R1, R2. Then I called the random function using the same seed value for both different variables using the lead number, and the result was the random function generates the same value for both variables when using the same seed number. It means that if you can guess the seed number that the application is using, we can guess the secret number to guess and win the challenge. Right here, I just bring to you secure random. The name is also telling us that it's secure. I tried to do the same process, so I just defined a byte array because secure random uses a byte array instead of strings as a seed value. And then I just created two different variables, random1, random2, and used the same seed value, and the result was two totally different values. That's why it's secure random. Exploit time. Now I'm going to show you some piece of code to create our exploit. We know what the application is doing. We know that it's using an unsafe random function, and now we can try to exploit it to make our proof of concept. Right here, I don't know if you all can see this code, but it's a piece of Java code. I'm just using the get runtime to execute some bin bash commands and use again the ADB to interact with the application. This exploit will just open the application, will input a number, trying to guess the secret value, the number we have to guess. We also are going to use our timestamp. There is another script being called right here, called timestamp.sh. I'm going to show you what the script is doing. And the output of this script is the init date from our exploit. Why I did this in Java code? Because my first tries, my first attempt was using the same Java util random to generate the same timestamp value and trying to guess what was the right number. So finally, I just use again some bin bash commands to call ADB again and using a lot of tabs. So basically, this application will start up the app, input some numbers, try to guess the system time current milliseconds, then we'll do an for loop by going through the application using tabs and enters to start it again. right here, I have the timestamp.sh code. I just modified the exploit to use this script because I realized that when we use the key code enter using ADB, the Android application generates a log. So for me, it was better to use this log time, because when we hint the enter number to try a new challenge, the application will you call the random function to generate a new file, a new number, sorry. And this time from the ADB logcat will be closer to our number than trying to guess only the timestamp. So I just use the ADB logcat. I just parsed the log and use gdate to parse this timestamp and get the same format the application was expecting, which was 3 numbers more in the length from the timestamp. Right here is an example of the ADB logcats that I told you. Right here, I just grabbed the key code enter, and in the beginning we have the timestamp, the exactly timestamp where I hit a new game, and mostly close to the just a second. I just lost my scope. All right. So this number will be more closer to the random value generated by the application. I just could try to do maybe generate a timestamp before hit the new game button, then generate another timestamp before I hit the enter, the new game button, and have a range between the init date and the end date to guess. And of course, sometime we will have the exactly timestamp for this application, but have in mind, we have only 10 tries for guessing. This is another video, because I'm not crazy to do it in the live. So I bring here just to show you this exploiting working, or at least kind of. As you can see, the exploit is already running. My exploit is just navigating through the screen and enter a number. Then we'll do a lot of tabs and enters to just put another number. Right there, I'm just using the seed value, using the timestamp that we have generated. And as you can see, the application told me, congratulations, you have guessed the right number in only 3 attempts. But as I told you, my exploit was already running. This is a short video. Every time that I run this exploit, most of the times I couldn't guess the right number, even abusing of the random function using a time-based approach. And why? Because I have only 10 guesses. If this application doesn't have this limit, of course it will work every single time that I run this exploit. But we have this limitation. So we have to take another approach to make this exploit better and improve this hit rate. I was very upset at the time because I was unhappy with trying to run this exploit a lot of times to guess the right number, and that's why I started to thinking another way to solve this challenge. And then I came in with an Android automation tool that's called UI Automator. This is a command line Android tool that came with the Android SDK. This UI Automator just let us to interact with the user interface showing us every type, every text field that's in the application using an XML file. So right here you have the help menu from this UI automator. We are going to focus only on the dump function that creates an XML dump from the current UI. This is a very simple, very simple example of a UI automator dump. This is just a piece of code from the guest button from the Mobile Hacking Lab Guest Meet Challenge. We are only seeing the features of this guest button. And right here, we can see everything about this button. We can see if it's checkable or not, if it's input text, if this button is clickable or not, if it's enabled or not. So we can see when the button is enabled or disabled from the application. Of course, if it was a input text, it will tell us if it's a password field or not. And finally, we have some bounds, which are the coordinates from this button. And we can just hit this button using these coordinates instead of using tabs and a lot of tabs to navigate through the application. So this is a very simple example. After, I'm going to show you the raw dump for you have in mind. But remember, we can see everything that's in the UI screen using this automation tool. So now, all those informations that I told you before, that we have about the number is higher, the number is lower, the button is disabled, the button is enabled again, we can just use it to improve our exploit and have a better hit rate using our approach. That's why I came with the binary search approach, because once we have the information that the number is higher or lower, I can just use it to adapt to my exploit and just change the init date, the init time and the end number from my guessing. And right here, I just using, again, UI automator dump to grab a window.xml file. I just pull it into my local machine. Then I will parse this window XML file using document factory. And now, using this parser, I just can navigate through every node of this XML file. Right here is the piece of code that I'm just using to change the guest number that I'm going to try. And right here, I can see if the application contains the string is too high, try again, or it's too low. And I'm just to show you this exploit running. I don't know if you can see, but now the application started. Right here, in this left corner, we have the shot. Let me stop. I just tried, my range will be from 1 to 101, because in a for loop you have to decrease 1, doesn't matter. We tried a button, a number, 65. The application says to me, it's too high, try again. So now I know that the secret number won't be any value above 65. Then I tried, again, the 17, the number 17, and the applications said to me that this number is too low, and try again. So now I know that the secret value won't be any value below the 17. So let's the application continues. So now, as you can see, my exploit is adapting itself, just changing the numbers based on the screen, what the screen is telling me. Just let me show you again. And that's it. And we could guess our, oh my God, just stop it. I want to explain. My exploits just find the secret number in 4 attempts. And this, almost 99% of the times that I run this exploit, I could guess the secret number, because this approach was more effective, using the information that the application was telling me. Okay, all right. You are just asking yourself, you are telling me that there is an insecure random, and we are showing this exploitation for a vulnerable application, a challenge, and how do I use this in real life in some use cases? I just bring to you some examples. Right here is an application telling me that my email is invalid when I type the wrong email. This is another application that's telling me that my CPF is invalid. CPF is Brazilian ID, like your ID for your country. And sometimes the applications likes to do some validation into those IDs to see if it's a valid or not. Another example right here is this application is telling me that this username could not be found in the database. The same application, when I hit it, a valid username is telling me the password is wrong. So all those information on the screen, you can use it to create exploits, to use your creativity. You can use this information right now to automate some process as well. You are going to ask me, why don't you do this directly from the API and do a brute force using burp, intruder, or whatever? And sometimes you just cannot break the SSL PIN from an Android application, so you can still a valid approach to use this information and know if it's a valid or not. This is the raw dump from the UI automator in the left. Right here, I'm just trying to brute force a PIN, and the applications, when I type the wrong PIN, the application says to me, try again. And as you can see, using the UI automator dump, I can see this string, try again. So also I can use it to brute force some pins and see if it's wrong or not. Just to summarize this application, I just show you how UI Automator can be effective with finding vulnerabilities related to data excessive exposure. Also the power of UI Automator to interact with the screen. How to use it with ADB to improve your exploits, your navigation through the application. Also capturing logs and screen capture. Sometimes the application won't tell you on the screen what is happening, but sometimes you can see this information in the logs. You can also use it. And the limit is your creativity. The random function, it was an example, but you can use it in a lot of ways in other applications to create maybe some new exploits or break some code. Now, I don't know if I have time for questions. Thanks for watching. This is my LinkedIn profile. You can scan this QR code, and if you ask your password, just trust me, input this password, and that's it. Thank you. Questions? Some questions? Anyone wants? It's lunchtime, everyone's hungry. No questions. We want to have some lunch. That's it? All right. Thank you, guys. Thank you. Thank you very much. I have some pictures.